Welcome to Solving Radical Equations and Inequalities. Let's get started. So we want to be able to answer what are the steps to solving radical equations and inequalities. So you're going to need to learn those steps in this video. So here are the steps to solving radical equations. We have to isolate the radical first. That means we want to get the radical alone or by itself. So you're going to get rid of anything that's in front of the radical or on the other side of the radical. Then you're going to apply the inverse operation so we can eliminate the radical. That means if we have the square root of something, you're going to square it. Square both sides of your equation. If you're taking the cubed root of something, then you need to cube it. Cube both sides of your equation. Then you solve for x just like a normal algebra equation, and then you're going to check your solution for extraneous solutions. So that means once you get a number, so say you got all the way down to your answer and you got x equals 3, you're going to go plug this 3 back in for the x of your original equation and make sure that it works. Let's start with these two examples here. So the first step we said was to isolate the radical. That means we want to get this radical x plus 1 alone, so we have to get rid of this 2. Because it's 2 times the radical, we're going to divide by 2. And you do that to both sides because it's an equation. So now I have the radical of x plus 1 equals 7. Second step, apply the inverse operation. So since this is a square root, we're going to square both sides. And that's how I get rid of that radical. So x plus 1 equals, that's 49. And then just third step is to solve for x. So I subtract 1 and I get x equals 48. Now before I can say that's an answer, I have to go check it. I have to plug 48 back in for the x and make sure that all of this will equal 14. So 48 plus 1. 48 plus 1 is 49. The square root of 49 is 7. And 2 times 7 is 14. So because it works, that's a solution, and that's my answer for x. If this didn't work, then you would have no solution. This would not be an answer. All right, so let's look at another example. Again, the first step was to isolate the radical. So we've got to get rid of the 6. So since the 6 is being added to this, we need to subtract it on both sides. So now I have the cubed root of y minus 4 equals 3. Second step, apply the inverse operation. This is the cubed root, so we need to cube it. So that way the cubed root and the cube will cancel each other out. And then we just have y minus 4 equals 27. And then solve for y. So add 4. So my y is 31. Now, last step is to remember to go back and plug 31 into here and make sure that it works. So I have 6 plus the cubed root of 31 minus 4 equals 9. 31 minus 4 is 27. And the cubed root of 27 is 3. And 6 plus 3 is 9. So because that checks out, y equals 31 is definitely a solution. So that's solving radical equations for x. Go back, or y I guess in this case, but just solving. So if you need to go back and rewatch it to understand, then do that. Write down the steps if you're going to need to see that in your notes later. So solving inequalities are pretty much the same, except we have one step in the beginning that's different. We have to set the radicand greater than or equal to 0, and then solve for x. Set that aside. So this is, the radicand means what's under the radical. So if we had something like 2 square root of x plus 2 minus 4 equals 3, we would take the radicand, which is x plus 2. We'd set that greater than or equal to 0. Solve, so x is greater than or equal to negative 2. And then we would just set that aside. It's part of our answer, but then we go on and we solve this just like normal. Sorry, this would have to be an inequality. So it doesn't matter what this inequality sign is. we are setting the radicand greater than or equal to 0, and that's because we want what's under a radical to be positive. So once you've done that and you've set it aside, and then you just solve it like normal. Isolate the radical, apply that inverse operation, solve for x, and then your answer is going to include whatever you got for x, and then that original the solution that you got from the first step. And you're going to put it together in interval notation. All right, so let's try some examples together. So with the inequality, the first step is to take our radicand, which in this case is 2x plus 4 because that's what's underneath the radical. We're going to set it greater than or equal to 0 and then solve. So then I have x is greater than or equal to -2. So I'm going to put that aside. Now I'm going to go solve this just like I did those equations. Isolate the radical. In this case it's already alone, so that step is good. Then apply the inverse operation. So because I'm taking the square root, I'm going to square both sides. So 2x plus 4 is less than or equal to 16. Then I just solve for x. So subtract 4 from both sides. 2x equals 12. Then I'm going to divide by 2. X equals 6. Oh, I'm sorry. Less than or equal to. Don't forget, like I just did, keep your inequality sign the whole way down. And since I didn't divide by a negative number, I'm not flipping the sign. So now I've got that x is greater than or equal to -2, but x is also less than or equal to 6. So that means my answer, if I were to put it in inequality notation, would be -2 is less than or equal to x is less than or equal to 6. Since I wanted an interval notation, it's just -2, 6, brackets because they're equal to. So that means my x has to be between -2 and 6. And it can include the -2 and it can include the 6. Alright, so on this next example, we're going to do the same thing. First, you have to get your radicand, so that's what's under the radical, so it's only x minus 3. We make it greater than or equal to 0 because we want it to be positive. Then we solve. So x has to be greater than or equal to 3. That's one of our restrictions. Then we solve it like normal. Isolate our radical, so subtract the 2 from both sides. And I'm going to move over here. Square root of x minus 3 is less than or equal to 3. Apply that inverse operation. So to get rid of a square root, we're going to square it. So x minus 3 is less than or equal to 9. Then just solve. Add 3. And we have x is less than or equal to 12. So now I have that x is greater than or equal to 3, less than or equal to 12. It helps me to put it in inequality notation because that would be 3 is less than or equal to x is less than or equal to 12. And so then it's easier for me to put that into interval. But you don't have to do that conversion. You can go straight from here to 3 to 12. So x has to be greater than or equal to 3, but less than 12. So any numbers between 3 and 12 will work here for x. That's it. Make sure you write your summary and your questions and go back if you're stuck in any of those steps.